So we're the governors. Our project is to build a governor test stand. I'm Gerald Anglin. This is Blake Clodfelter, accompanied by Alex Fogel, Philip Lissy, and Benjamin Miner. Our goals. Our first goal is to actually come up with a governor test stand and test a UGA governor. This can be used for practical training in our MARE 312 class or marine diesel engines. It will also be able to be used later on in the future for testing on the USTS general rudder. Our main focus with this governor test stand is to put in different load changes and see how the speed group may change throughout these load changes. We also want to include a graphical comparison of different changes that include group speed, speed setting, and load limiting. As far as costs go, a commercial governor test stand costs upward of $10,000. With our governor test stand, we are well under that with around $1,200 at the moment with 65% complete. And later on, we are going to make it compatible for this governor test stand to be able to take different governors with just a little bit of change in the design with the coupling and the governor mounting.
So where we're at, we split our timeline into two major components: our mechanical build within that, and the electronics of the system. Right now, we focus, the build team's focused a lot onto the mechanical build, and we pretty much finished it all up besides just painting and preserving. And the administrative team has been working on getting all the electronic designs and collecting the components, and we're about ready to start wiring that all up. Our goal is to do our first test on April 26th and do our modifications over the next couple of days before turning it in.
So challenges. Every project you always have challenges come up that you didn't foresee at the beginning. Our main challenge was we underestimated the complexity of our project. So to combat this, we've consulted more with Drake Controls, our head benefactors. We've formed a smaller project team to focus on just the technical aspects of our project. Another challenge we came up with, or we ran into, was the difficulty in trying to have our project cover a wide range of governors. So now we focus on just one governor that can run the gamut of all the aspects we wanted to show using our test stand. We also were told that our presentation wasn't showing what we used in our previous coursework. We didn't include any of our prior knowledge or anything we've been taught. So now we've used work packages that include our knowledge from our marine diesels class, our materials class, and our welding class specifically.
So to overcome the challenges that Philip had just mentioned, we divided our team into two main components: administration, operation/execution. The administrative team immediately identified a comprehensive work package timeline that we could use to facilitate work items for execution, which were then resolved and applied and analyzed by the execution team. Next, please. So the team divided us in two divisions, as I mentioned, where the administration team developed those technical work item specifications, including subject references, materials, and procedural guidelines that the execution team could use. Next, please. We also utilized common engineering programs such as AutoCAD to develop dimensions, to develop analysis of components, put-togethers, and couplings of individual components through those technical work item specifications. Next, please.
In addition to the mechanical portions, we have been developing the documentation for our electrical power supply system, as well as our electronic instrumentation and control. We have faced several difficulties with this, though. One of the big problems we had to resolve were the various power requirements of our major electrical items. This included the 4 480 volt three-phase power required by our VFD and motor, as well as the 110 single-phase power required by our oil pump, and the low voltage DC power required by our instrumentation and control. To remedy this, we took a single-phase tap off and transformed that from 480 volts down to 120, and are using a simple commercially available plug in order to directly plug the oil pump assembly into that, as well as use a commercially available AC to DC rectifier to provide our instrumentation and control power. In addition, since getting the VFD, we have been able to begin to identify and solidify our instrumentation and control plans and determine exactly how and where we're going to integrate our VFD with our PLC with our signal inputs.
So again, going forward, so we're utilizing the AutoCAD and OrCAD softwares, which are common engineering platforms, which we feel will provide a clarified technical guidance. We've reestablished our reference list through smaller teams, which can then pull references and statements from those references to utilize in the work packages. We've also identified solutions and mitigating measures through a faster lines of communication, and that came from consolidating the build team and design team through individual leads, which meet on a regular basis. And lastly, we addressed issues much quicker and really remedied one of the major problems we had initially on the project, which was indecision, and we resolved that through more stringent research and communication. Next, please. Currently, as mentioned, we're about 65% complete on the project. As you can see here, this project has also now been painted and put together to include a gauge board and stand setup. Next, please. We'd like to take a moment to thank our sponsors, which included Drake Controls, GM Welding and Machining, Texas Electrical Machinery, and Farmers Copper.